Good afternoon. In this video, in the geometry series titled Angles of Triangles, I am going to give you examples on how to use the triangle sum theorem and the exterior angle sum theorem to find angle measures and how to set up equations to solve for value for x or solve for a variable. Let's begin by first going over the triangle sum theorem. The triangle sum theorem simply states that the interior angles on a triangle are equivalent to 180. The sum of the interior angles of a triangle are equivalent to 180 degrees. So meaning if I add again these three angles, these three inside angles here, as illustrated right here in this equation, my answer is going to equal to 180 degrees. And the exterior angle theorem states that if we extend the triangle to on one side, this exterior angle that we create, let me highlight it in yellow, this exterior angle that we create here is equivalent to the sum of the two remote interior angles. Notice how these two interior angles are not adjacent to angle number one, so not this angle here, but the two remote angles, the sum of these two angles will be equivalent to the measurement of whatever this angle outside here is. So for example, this angle up here is equal to, let's say, 80, and this angle down here is equal to 60. Then the measurement of this angle number one will equal to 120. Or vice versa. If this is equal to 120 and this one is equal to 60, then this one, no, not 120, what am I talking about? 140. So if this angle is equal to 140 and this angle is equal to 60, then this angle has to equal to 80, because again, these two add up to that number out there. So let's look at examples of how we use the exterior angle theorem. Well, the most basic idea here is, if you see like on example number one, notice that the three angles are all inside. So adding these three angles, adding these three interior angles here, the 37 degrees and the 24 degrees. And again, this angle just means angle 1. That's not like 1 degree, just the name of the angle is angle 1 instead of using a variable. Then these three angles would have to equal to 180 degrees. So the way we could figure out this missing angle is to get 180 and subtract the two values that we know. We could subtract the 24 and the 37. So that's equal to 156. And then subtracting 37 is going to equal to 119. So the measurement of that is equal to 119. Which is the same thing as getting 180 and subtracting the sum of these two, which is 61. 61, sorry. 61. And that's equal to 119. On the second example, since the third angle that's given to us is on the outside, notice again we extend this triangle outwards and we have this angle right here. Well, the measurement of that angle number one is equivalent to the sum of these two angles here. So adding 76 with 52, which is equal to 128, is the angle measurement of that one right there. So that's equal to 128. And the other application to the exterior angle theorem is if we're given the outside angle instead. So like right here in the third example, we're given that this outside angle is 74. And well, again, since the sum of these two angles, adding those two things is going to equal to 104, I can figure out the missing amount by getting the 104 and subtracting it by the 79, which is equal to 25. So these are some very fundamental, some basic ideas on applying again these two theorems. And let's see how we can apply these two theorems in a little bit more complicated examples. So let's look at example number 4. On this example, we have noticed that we have again this big triangle, and by splitting it into two parts, by starting at a vertex and drawing a line to one of the edges, the opposite edge, we end up creating again two triangles. We end up with this yellow triangle here and this orange triangle over here. So let's start with the yellow one. Well, in the yellow triangle, notice that we're only missing angle number 1. Again, this angle right here, that's this one up there. And since the two interior angles that we have are 66 and 84, which is the equivalent of what? 150. If I take 180 degrees and subtract the 66 and the 84, which is the same thing as subtracting a total of 150, I get that the measurement of that angle is going to equal to 30. So this angle measurement up there is equal to 30. Now, the way we're going to figure out angle number 2, there's two ways to figure out angle number 2. And I'm going to do angle number 3. This angle right down here is by doing the following. Look at this. If I extend this out, okay, I got everything, but if I extend this out, I know that this angle down here is 66, and I'm looking for this angle right here, angle number 3 right here. Well, if I look at it this way and ignore, essentially, you know what, let me get a white, and let me make this a little bit bigger, and I ignore all of this, okay. Notice that I have extended this triangle. This is probably a little bit better to see. I have extended this triangle down here, and let me erase this number right here, and I know that this number there is equal to 30 degrees. So using the exterior angle theorem, angle number 3 is on the outside of this triangle here. So I can figure out the measurement of this angle here by adding again these two amounts, by adding this angle and this angle right there, the two remote angles, the two angles that are not adjacent to this exterior angle, and adding 30 with 66 is equal to 96. So the measurement of angle number 3 is equal to 96. Now that is not the only way to verify this angle there. Okay, let me put all of this back on. This is not the only way to figure out the measurement of that angle that way. Another way of figuring out that angle measurement is by doing the following. Since this line here, I'm doing red, is a straight line that's broken up into two parts, angle 84 and angle 83 are a linear pair, meaning again that they are supplementary. So if you recall again this definition from our unit 1 lessons, supplementary angles or linear pairs in this example add up to 180 degrees. So the 84 and whatever this angle measurement is has to add up to 180 degrees. Which means that I can figure out this angle, angle 3, by getting 180 and subtracting it by 84. And well, wouldn't you know it, that's 180 minus 84 is equal to 96. It's equal to 96, which is exactly what I got by adding the 30 and the 66, by adding again these two remote angles. So even though angle 3 is on the inside of another triangle, it is not on the inside of this yellow triangle, and as a result, we can use the exterior angle theorem. So it's up to you to decide what you think is easier to understand and what makes more sense to you in figuring out what this measurement is going to be. But But the case that where this is going to always be a linear pair, it is always going to be a linear pair. And now that we know that that angle here is equal to 96, let me write this number right here, 96. I can now figure out the measurement of angle number 2. Let me circle it in green, that angle right there, by getting 180 and subtracting the 96 and the 43, which is the same thing as basically subtracting 139, yep, subtracting 139, which is equal to 41, so 41 degrees. So let's look at the next example. In our next example, we have a similar situation. The triangle is just simply written back upside down. Okay. We have two triangles here that we can work with. We have this triangle here. And then we have this yellow triangle here. And we're trying to figure out the interior angles to each one of those. So on the green one, we can figure out the measurement of angle number 1, that angle right there, by simply subtracting from 180, subtracting the 90 and subtracting the 43. So again, I could do it one step at a time, subtract 90 first, then subtract the 43. Or I can simply subtract the total of those two numbers, which is 133. So 180 minus 133, that's equal to 47. So angle 1 is equal to 47. So that is equal to 47 right there. And I can figure out now the measurement of the other two angles by doing something again very similarly. I can figure out the measurement of angle 2 in one of two various ways. Like I said, since angle number 2, this angle right here, angle number 2 is on the outside of the green angle, this green angle right here. If I get the two faraway angles, which is the 90 and the 43, and add them together, that's going to be equal to this outside angle right there. So 90 plus 47 is equal to 137. So that's the measurement of angle number 2, 137. Now the other way I could figure out that number 137 is by using again my linear pair. Since these two angles, angle 2 and angle 43, are an example of a linear pair, if I get 180 and subtract the 43, that's equal to 137, which again is the measure what this has to equal to in order for these two angles to add up to 180 degrees. So you see, I end up with the exact same number. And it's up to you again to decide what makes more sense and what actually works for you better. And now with those two angles, with knowing that, well, with this angle, knowing now that this angle is 137, knowing that this angle down here is 12 on the yellow, we can now figure out the measurement of angle 3 right there by getting 180 and subtracting 12 and 137, which is equivalent to subtracting 149. We end up with a total of 31 degrees. Now in example number 6, notice that we have again now two triangles but they are facing each other. We'll start by first identifying again the measurement of the missing angle on this top one, this yellow one. And so that's angle number 1 right there. So getting 180 degrees and subtracting again the 66 and the 61, which is equivalent to subtracting 129. We end up with 51 degrees. And the way we're going to figure out the measurement of angle number 2 is quite simple. If you recall again from our unit 1, and if you haven't seen these videos, you could go back to unit 1 and angle relationships. These two angles here are vertical angles. Angle 61 and angle 2 are vertical angles because they're created by intersecting lines. So we have this straight line and this straight line intersecting at this point here in red, which means that angles that are opposite to each other, like 61 and angle 2, are equal to each other. So that means that angle 2 is also going to be 61 degrees. And thus, our orange triangle, the only angle that's missing is angle number 3. So 180 subtracted by the 61, this is 61, and the 90-degree angle there, which is the same thing as just subtracting 151, we end up with 29. So that's the angle measurement of angle 6. Now for angle 7, or example 7 better said, finding the interior angles here is going to require us again to recall prior knowledge about bisectors and what bisectors do. So bisectors create two equal parts, and in this case angles. We're talking about angles here and not segments. So two equal angles. But again, anything that bisects is creating two equal things, two equal parts. So this red line here, BC, all right, which let me highlight it in red, is going to bisect the angle A from point A to point B to point D, which is this angle right there. Therefore, this 90-degree angle, because that's what the measurement of this angle is, let me do it in blue. This angle right here is a 90-degree angle, as indicated again by this square right there, is going to be divided into two equal parts, which means that angle 2 and angle 3 are both going to be 45. Two equal parts. Then, to figure out the measurement of the missing angle in the yellow one, which is angle number 1, we're just going to do the same thing. Get 180 and subtract the 48 and the 45, which is equivalent to subtracting, what's that, 93? We're going to end up with 87. So angle number 1 is equal to 87 degrees. Now angle 4 is not 87, okay? Do not get that twisted and think that angle 4 is going to be 87 also because of the red line. The red line is cutting that angle also in half. No, this red line is only cutting the 90-degree angle, only this angle right here into two equal parts, not this angle right here, not this angle. This angle is not being cut into two parts, only this angle down here, okay, the 90-degree angle. So the way we're going to figure out the measurement of angle 4 again is to get 180 and subtract the 45 and the 83, which is equivalent to essentially subtracting what, that's 8, 12, 128, which is 57. I'm sorry, 52. So there's the measurement of those four angles there. Now for our last two examples, we're going to use again those angle theorems to figure out what the value of x is and then figure out the measurement of DEF here. So here we want to figure out the measurement of DEF. So from point D to point E to point F, DEF, that puts the vertex again in the middle, E, right here. So we want to know the measurement of this angle. So from point D to point E to point F, that's that angle. So DEF is 9x plus 3. Well, the only way we can figure out the measurement of DEF is to know what the value of x is. We need to plug in a number in for x. Well, the way we're going to figure out that measurement is by using the triangle sum theorem. So the three angles are inside. Adding the three angles has to equal to 180 degrees. So if I get 9x plus 3 added with 5x plus minus 2 and then added with 11x minus 21, That's going to equal to a total of 180 degrees. So the way we're going to add these things together again is just by, from Algebra 1, our rules about combining like terms and simplifying stuff like this is to add all my like terms. Add everything that has an x, all my variable terms together, and then all my constants together. So adding 9, 5, and 11, that's equal to 25. So that's 25x. Adding all the constants together, that is equal to negative 20. And that's going to equal to 180 degrees. And then solving our equations, well, we'll add 20 to both sides. So 25x is equal to 200. Then dividing by 25, x is equal to 8. So with the value of x being 8, I can now plug that into my expression here. And I get 72 plus 3, which is equal to 75. So that's the measurement of DEF of angle. The measurement of angle DEF is going to equal to to 75 degrees. Now, on our final example, we're going to use the exterior angle theorem to solve an equation and figure out the measurement of angle DCB. Well, let's first find out where DCB is. So from point D to point C to point B, DCB, that's this angle right here. And that has this measurement of 18x minus 15. So let me write that down. So angle DCB is equal to 18x minus 15. Well, again, just like before, we can't figure out what this is equal to unless we know what the value of x is. So using the exterior angle theorem, we're going to figure out what the measurement is by, again, adding the two interior angles. So here are two interior angles, angle A and angle B. And the exterior angle is, again, that DCB, this outside angle. So adding the two interior angles is going to equal to this outside angle. So I'm going to do this work over here. So adding 13x minus 11 with 4x plus 1 is going to equal to the exterior angle of 18x minus 15. So combining like terms, we end up with 17x. Combining the constants, minus 10 is equal to 18x minus 15. And then using our little acronym, letters to the left, numbers to the right, variables to the left, numbers to the right, we would move the 18x to the left side, making it negative. We'll move the constant of minus 10 to the right, making it positive. And then we combine like terms. So 17 minus 18 is equal to negative 1. Negative 5 plus 10 is equal to negative 5. And dividing by negative 1, we get that x is equal to 5. And now we can figure out the measurement of angle DCB because we can now substitute in 5 for the value of x. Well, 18 times 5 is equal to 90. 90 minus 15 is equal to 75. So that's the measurement of this angle here. That measurement area is equal to 75, which happens to be the exact same angle measurement as the other one. What a coincidence. So this is again our examples on how to use again the exterior angle theorem and the angle sum theorem. So it requires again to simply understand and again see the and the differences between that. On these examples, these two angles add up to give you the outside angle But when you're given all three inside angles, then adding them is going to equal to a total of 180 degrees. I hope these examples were helpful and clear. Like I said, I hope these examples were helpful and they were clear for you. And again, I thank you for watching. And if you haven't subscribed to my channel, please do so. And I hope you have a great day. Thank you. Goodbye.